All right, let's get going with this. Before we start, I do want to make sure that we are aware of what kind of drives me, and that is the ability to have nice things. I come from a world originally in design and art, and it was totally encouraged to add all of the things that we would want to have for a design. We weren't told to limit what it is that we want to make because there were no limitations. There was nothing standing in our way and no one telling us to, hey, don't do that, for various reasons. I like to think that we can still have nice things. Um, Especially now that we are in the web. We deal with a lot more restraints and a lot more that could go wrong. So, with that in mind, let's talk about how we can do that by building delightful UI, delightful apps that perform that our users would like, all while keeping the performance of those apps in mind. I'm Mike Hartington. I am director of DevRel at Ionic. You can find me for now, I guess, on Twitter as M Hartington. Whatever network we all might be migrating to, I will still be M Hartington. Um, the benefit of having a unique last name is that you just slap your first initial on there and it carries with you for the rest of your life. So, uh, diving in, we're talking about performance a little bit. Um, Performance is a very, very loaded topic. You could be talking about parse time, talking about download time. You can talk about uh, micro interactions that the browser has to perform as you are doing whatever happens in your app. Or you could be talking about rogue observables, killing your performance and opening memory leaks, right? There's a lot that can go wrong and a lot that should that we as developers have to keep in mind. I'm not going to talk about that. I am not the person to talk about that. I could, but there are other people who can talk about to more with more authority. I'm going to talk about UI and UX features because that's where I feel like I know a little bit more. The things that we're going to talk about, how we can have animations inside of our apps, how we can have UI changes that stick to this 60 frame per second kind of limitation that we want to have, and then this non-blocking interactions or operations that we can have inside of our app, so that way users don't notice long-running tasks happen. We're going to dive into this, and we're going to also start off by stating that all of these things are really, really challenging. Um, there are whole professions that are all segmented on doing this kind of performance review and doing this kind of performance implementation. Hopefully, you'll be able to leave here and have some tools and tips to be able to uh, dive into that realm or inspect some of this stuff yourself. Um, we're not going to sugarcoat it. This can be challenging, it can be confusing, but kind of take it piece by piece and understand that these aren't things that you can learn in 30 minutes. These are things that take months and months. So, this is all derived from this knowing me coming from Ionic and coming from this cross platform realm. I've heard this statement quite a bit where people will complain about an app not feeling native enough. And, a lot of this comes down to the expectations that native apps have set up for users. People expect their apps to be fast and to stay fast. People expect things to be near instant in their interactions and not have to wait one, two, let alone 500 milliseconds. People are trained, and we as web developers, we don't necessarily train people that well, unfortunately. Native gets a lot of the stuff for free, and we as web developers have to either re-implement it or, we build bad products. I mean, for example, this is Apple Music on an iPad. Now, as you open up and start to play a song, you can toggle play and pause, see the album artwork shrink and scale with a very, very convincing shadow and elevation effect. You can toggle to the next song and see the background colors update automatically. And then you can toggle the queue of songs that you have without having any layout jumps or jank in there. As those actions are being performed, it's incredibly smooth. It's incredibly fast. It feels natural. And this is a really nice thing. These are features that I don't think Apple Music should ever remove because they kind of makes Apple Music its own. These are unique features that are always going to get cut first in terms of performance on the web, and I don't think we should be doing that. So, I proposed myself a nice little challenge. I want to rebuild Apple Music using web technologies, and I broke down those characteristics and those things into three different parts: animating the right things, handling dynamic and background or dynamic and unknown animations, and then also handling background changes. Um, like I said, this isn't stuff that you can just learn like right away. It takes time, and luckily, I had like I don't know, going on to 3 years of time to be able to learn this stuff. So let's dive into it with our first example. I am going to preface that this was built using Ionic and Angular. None of it, though, is like framework specific. This same kind of stuff could be material in Angular. It could be your own homegrown CSS solution and React or Vue or no framework at all if that's how you want to roll. All this stuff can translate pretty well across technologies as it should. So let's start off with this animating the right things. And I'm going to target this illusion of elevation that Apple Music has. And just to refresh your mind, we have this play, pause, and the album scales. But then right in the background, there is a shadow that is correctly respecting the height of that card. So it's not only just growing, it's also diffusing to the sides and then also down below. So the shadow is pretty complex. The animation for the artwork scale fairly easy, but that shadow is really really challenging. So did what any other developer would do. I went onto the internet and I copy and pasted some code that I found from a website. In this case, I went to Angular, or I didn't go to Angular Material. I went to Google Material, and they had a really, really in-depth guide into elevation and how they solve it. This is actually a really, really good resource to have, where they actually point out how you can have several degrees of elevation and have a rhythm between each one of those steps. So that way the shadows feel nice and natural. So I copied some code from here, got the closest that the card could be to the surface, and then I got the most distance that the card could be from the surface, and I threw it together, and I got this. Now, it might be hard to see this in the stream, but what we have here is just a shadow that is animating using some keyframes to just kind of stress test this. And this shadow is just scaling between two values, going from like 0 to 50 to 100%. Not too complicated. The problem is that these shadows are terrible for performance. Any drop shadow or box shadow is terrible for performance because of how the browser has to handle them. Once you add a shadow in your app, you are now asking the browser to do extra work to figure out, here's a shadow, there's a color behind that shadow, and then calculate the difference between the background color and then the shadow, and then figuring out all the steps in between to account for the shadow's spread. That's a lot of work. Try animating that, and now you're going to compound that amount of work like by a lot, and then that's just going to crush your app's performance. You're actually going to be able to hear your laptop's fan start to go off. And what's worse is that as this is happening, your battery's getting impacted by this. So not only are your fans spinning, but your battery is probably going to die before the shadow becomes more performant. So avoid shadows. There's a really cool tool out there. I think it's called Stylint that will allow you to ban a certain property. Add that into your code base, ban box shadows, tell them Mike told you so, and you'll thank me later. We can see how this actually happens by using some tools in the browser's dev tools to actually see um, the shadows in the affected areas. So here we have the shadow animating, and it's that inner box that is scaling. And you can see all the areas around this shadow that are getting affected. This is called repaints. And these are repainting every single time that shadow is hitting a step in that animation. So let's go over actually to the app itself. And we have that shadow happening here. This is just, I made sure that the shadow was nice and red so that way we could see it. Let's go ahead and open up DevTools. And I'm in this rendering tab. If you don't have that, just click this plus and select it from the side. But let's go ahead and select paint flashing. And lo and behold, we have our repaints. This is all the problem parts in our app. Now, it's not going to seem that drastic on a fairly powerful MacBook Pro, but let's assume the worst situation and go for a 6x slowdown of our CPU. Now, if we go over to this performance monitoring tab, we can start to see the impacts of this pretty significantly. And let me just bump the size of the dev tools to make sure that this is clear. Right now, we're at like 40% CPU usage for the shadow, and we're doing about 120 style recalcs. This is terrible. This will kill your users' devices, laptops with emulated CPUs, or even your modern Android device. They would not be able to handle this, and people will be very upset with you. So let's go over to the performance and see how we can fix this. So I'm in my app. I know where this part's going to be. Go to our artwork, and here is the code for this. Right, we are just going between two box values or box shadow values, multiple steps in those shadows, and this is killing our performance. So let's go ahead and actually just comment that out. And instead of using box shadows, let's use, there we go. Let's use a pseudo element. Because really, what is a shadow? Shadow is just another element being added to our DOM, right? We can mimic that ourselves. And instead of using box shadows to transform or go between different states, let's just use transforms and translate that stuff. We can use a scale 3D, and then in our actual transforms for the keyframes at 0 and 100%, so whenever the card is towards the surface, we scale down and we center it. When it's at 50%, we scale it up a bit, and then we go ahead and we push it down a little bit to simulate that effect. Let's go ahead and save this real quick. And we'll come back over to the to our app, and let's go ahead just make sure that we have everything enabled. Yep, paint flashings are enabled. Instantly, we have no green frame pointing out that we are repainting too much. Automatically better. Be happy about that. Performance, if we go down to our CPU, we can jump over to the performance monitoring and see what we got. Now, I will point out that there is a little bit of CPU usage because of the stream and everything, but going from 40% to maybe top off at 1%. And then the best part is that these style recalcs are sitting at 0. So we aren't recalculating the styles and repainting every single time, and we're not hitting our CPU every time we need to animate something. This is a far better implementation for not a lot of extra code. And actually, we're going to close this because I know that the browser will start to flip out a little bit. So I had this pre-prepared just in case, but just to recap what we did, we went from 16 lines of code to have a shadow, and then a few more lines of code for far better performance. And if we look at the other one, we had multiple shadows, right? This is a multi-step complex shadow. Instead of doing just a pseudo element, you could wrap this in a component and then have these inner shadows that you can modify and do whatever you want with. And then you, as a consumer of that component, don't need to worry about how those shadows behave. You just need to make sure that uh, you're using the correct way to animate them into transition between different states, which are to use transforms. All this can be componentized, that way you never have to think about it. So afterwards, as you saw, we have it. It's a lot better. It's a lot smoother. Better for our CPU, better for the browser, and better for the users. And plus, it's a pretty cool effect. So we can animate the right things. We can animate shadows. We just have to be smart about how we do it. What about our next goal? And that is these dynamic and unknown animations. Just to make sure we're aware, it is this kind of hiding and showing of the cue as it gets added or shown in the DOM. I had tried this before, and the difficult part about this is when you start to animate one thing, as soon as the other element gets added to the DOM, it can be basically impossible to know how to react to that. The layout shifts that can happen as soon as things get added to the DOM are near instant and can be really disrupting to existing animation flows. I almost gave up on this. And this is when I found Paul Lewis's very well-known article, Flip, and I finally decided to actually pay attention and read it. So what is Flip? Flip is an acronym because why wouldn't the web have another acronym for things? We have first. Basically, first is going to say get a snapshot of the DOM node, get the X and Y, width and height, what have you, and save that to memory. Then you're going to cause a layout shift that's going to put the element in its final or last position, and then you're going to get a snapshot of that. X and Y, width and height, all the stuff that you need. Well, now you know the start and the end positions. Figuring out how to animate between those is fairly simple. You do some math and invert those values to basically put the element back where it was originally, size, X and Y, and everything. And then you create an animation that will tween between those two values, and then you play it. And it seems like the animation was expected from day one. So we can look at this, how this would work in our app. Now, this is a lot of code. The animation code can be quite complex, so we can break it down, and this is an actually simplified version of what I finally used. We get our elements from the DOM. We have the queue of songs and then the central player. And then we get their width, height, X and Y. Now we go ahead, we toggle that class list, or we'll toggle that class for active, and then we go ahead and we get those X and Y values again. Now we just start doing basic math. We do left pre and left post. We do subtraction. We do subtraction of top from the pre and post, and there's our delta. For the width and height, we can skip the math altogether and just do a comparison. Was the value less than 1? Okay, was it 0? If so, here's one value. If the value is greater than 0, use this. You don't have to do too much math. You just get the numbers and you figure out how you want to handle them. Once you have those deltas, creating the animation here is fairly simple. We use this from to function to transform the from value to the to value for the transform and scale 3D. And then we use from to on the opacity to scale from the from value to the to value. And then for the track player, we do the same thing. In this case, we have a little bit of extra work here because we want to handle how the transforms actually happen. But once we have all this together, this is what we get. Now, this animation is using the simplified one, so we're not handling the exit animation properly. But you can see as the elements animate in on the right-hand side, the artwork and the track appropriately adjust and feel right at home. And because we're using JavaScript, we can be clever and we can start to do different animations altogether based on the orientation of the device. If you're in portrait, this is how the animation should work in native. Let's respect that. These animations did use Ionic's animation API, but you could do it with vanilla web animations, right? You don't need to use Ionic in this case. And in fact, there's a really great plugin from GreenSock called Flip that'll automatically handle this for you. You basically give it the parent container, and then it will watch for elements being added to that container and then animate them appropriately using Flip. So super cool. I have no affiliation with GreenSock. I just think it's pretty awesome. And if you do give it a shot, be sure to tell Cassie Evans on Twitter that you loved it, because she has done a whole bunch of work to promote it. Okay, I know it's almost toward the end. We got one more section, and it's this background reactive changes. Basically making sure that we can do this, which I thought was the coolest thing, and that is that the album artwork will automatically dictate the background color of your track. So we'll kind of go right through this, because this is not something that I had a struggle with. I actually had done something similar before, and I found a library that can help, and I want to improve it and make it faster. So there's this library called Color Thief, where you will give it an image, and it will extract all the colors, do some math to figure out what is the most common color, and then here are the subsequent colors that are also pretty common in there. In this case, we gave it a plate with some snacks on it, and it said, hey, that plate is really the dominant color in this photo, and then here are the subsequent colors here. Feels right. Just by looking at that, you can tell blue is the dominant color. I wanted to rewrite this library because it was all done in the main thread, to use a web worker and an Angular directive to react to whenever that image change and fire off an event. This was also an excuse just to play with web workers, because I never really had a reason to. So I decided to go down this route, and this is what we got. So this is the actual directive minus the worker logic itself. All we have is probably 70 lines of code minus imports. So to start off here, what we have is this ng on changes. We're just manually listening for whenever the source attribute has changed on our directive. This was using Apple Music API, and they do some really weird stuff where they'll give you 5 images in a row, and it's the same image, it just has different query params, and that will trigger source, or that will trigger ng on changes. So you have to kind of get a unique version of it anytime the image comes through. So in this case, we're just doing a really simple comparison. And then we call this get palette from URL. Get palette from URL downloads the image, and then we store it in an image object. And then we pass this to this get palette function, which will go ahead and create a canvas for us. It'll place that image in the canvas, and then it'll get the data from that canvas, aka the pixels, and then the pixel count. And then we go over here and we post that to our web worker. The web worker is going to take the pixel count, the the actual pixels that get extracted from the canvas, the color count and quantity or quality of our sampling. It'll churn those numbers, figure everything out, and then up here we can just listen for that on this on message. Once we have those numbers, we're just going to remove the canvas to do some good cleanup, and then we're going to emit that data, and we can use that in our app however we want. In this case, this is what I did. So I would just skip to the next song, and then you can see, boom, here we go. We now have a green color as our background, and we're animating between this by just changing the CSS, a CSS variable, so that way it's just handling everything together pretty nicely. So I'll keep this on the screen for a second. You can see how this app has evolved as I learned all this stuff, and it's even further along today. So you could go to startrekng.web.app, or you can scan this QR code, and then you can walk around and see how it works. Let's actually go ahead and I have a second. I'm just going to go ahead and do it. Let's see. We'll go to lo-fi hip hop because this is one of the few things that kept me sane during the pandemic. We'll hit play, and I think I can't mute it here, but you can't hear the music, but I can, and it's super relaxing. So here we go. We have the entire thing playing. Let's go to the next song. We can see how that has changed. All the play, pause, all the shadow effects are still there. We can even see how the cue works and how, as the elements leave, we're able to handle that animation. In fact, we can go all the way to our portrait mimic, and we can see that this is going even further too. So again, that URL, startrek-ng.web.app, or scan the QR code. This was like just a really over-engineered demo and a passion project that I actually use to this day. So wrapping up, keep in mind, we can have nice things. We can have cool stuff in the web, but also keep performance in mind by just being a little bit smarter than we typically are. We animate the correct things. We don't use box shadows at all. Ban them from your apps. We use flip animations to handle complex transitions. And web workers, because they're a really easy and cheap way to do a lot of complex computations and offload them so that way we're not blocking the main thread. Think about your apps. You probably have some kind of situations where maybe it's not the exact stuff that we looked at here, and the exact situations, but you can find some places where you can get those small wins inside of your apps. So, again, I'm Mike Hartington. Thank you for hanging out. Hope you all enjoyed it.